Hi friends, have you ever thought how a ceiling fan is made to be a self-starting motor? We are giving it only a single phase AC supply, but how rotating magnetic field is produced to make it a self-starting motor? So you can see friends, we are not applying any mechanical force. It is made to be a self-starting. How is it possible? In this video I am going to explain that. We have a ceiling fan and we are giving it a single phase AC supply. So by using only a single phase we can make it rotate, but initially some torque should be applied externally. By using a stick we have to apply a small torque to the wings of the fan, but always it's not possible to apply external force because it is installed at some height. So uh, by using a single phase AC supply we have to produce a rotating magnetic field. So we have to split our single phase into two phases which are at 90 degrees out of phase apart. So now we will see how to split a single phase AC supply into two phases by using which components. We can split an AC supply, a single phase AC supply into two phases. So friends, if you see inside a ceiling fan, there is a starting winding which is called auxiliary winding, and another winding is there, main winding which is also called as running winding. Their internal connection you can see, and they are wound around a rotor they are wound. So friends, starting winding is connected in series with a capacitor, also called as condenser. It is starting winding is connected in series with a condenser, and a parallel voltage is applied to those two windings. 240 volts AC supply. Same voltage is applied across main winding and this branch also. And I have told you earlier that we have to split a single phase AC supply into two phases that are out of phase to each other. So we are providing a single phase AC supply, and that is split into two phases. Here one phase and here another phase. They are 90 degrees out of phase to each other. So how is it possible? So initially we have to consider this branch. An inductor is connected in series with a capacitor. That means RC circuit we have to consider initially, because why I have said RC circuit, here inductance is very low, we can ignore it. So RC circuit or some resistance, it has some resistance, and to that resistance a capacitor is connected in series. So we have to consider RC circuit. So we are going to see the properties of an RC circuit. So here we see an RC circuit properties. I hope you know the properties of an RC circuit. This is the current across resistance, and this is current across a capacitor. We know the current across a capacitor leads by 90 degrees. It is through resistance and it is through capacitor. So the net current, the resultant current would be this one. So it's making, what we get from this diagram is resultant current is making some phi1 angle with our single phase AC supply. So by connecting a capacitance in series with the resistance of starting winding, we can make the net resultant current making some phi1 angle with our AC supply. Now we have finished this branch. So now we are going to this branch. Only inductance is there, no resistance, because copper winding wire gauge is used such that a less resistance is provided to this winding. So we can ignore the resistance through this winding. So only inductance is there. So coming to this diagram, current across an inductor lags behind the current. Lags by how many degrees? 90 degrees. So the net current will be like this. So by adjusting the values of resistance of two windings, we can make this current and this current make 90 degrees out of phase to each other. So they are separate windings. This one is making 51 degrees out of phase with our AC supply, and this one is making 90 degrees. So we can adjust the resistance of this winding and make these two net currents make 90 degrees out of phase to each other. Finally, what we can know from these diagrams is phi2 minus phi1. The difference between those two angles can be adjusted. It can be adjusted to our desired value. So finally, what we came to know is the current across this branch is making 51 degrees with this signal, this voltage signal, and at the same time the current across the main winding, across this branch, is making 52 degrees with the signal, AC supply. So both are making some angles with our input signal. So by adjusting the values of capacitance, inductance and resistance, and this inductance, we can make the difference. Phi2 minus phi1 is equal to 90 degrees or some desired value. But what is the use of doing so? Creating some phase difference, what is the use of doing so? What to do with this phase difference? We know when current flows through an inductance, it creates a magnetic flux around it. We know that. And here one inductance and another inductance is there. So they produce magnetic flux around them, which depends on the current flowing through them. So here one current flows and here another current flows. The magnetic flux produced around them depends upon the current which flows through them. But those currents, this current and this current, are making 90 degrees phase difference with each other. So now we are going to see how this phase difference can be used to produce a rotating magnetic field, which can make a ceiling fan self-starting. So friends, consider the current across this branch is I1 and the current across this branch is I2. So they are making 90 degrees with phase difference with each other. Here you can see the diagram. I1 current is leading I2 current by 90 degrees, and I2 current is lagging behind the I1 current by 90 degrees. Friends, I don't say that the internal winding arrangement in ceiling fans is exactly like this, but I just want to explain the basic principle, and the phase difference between I1 and I2, how it is used to produce a rotating magnetic field. So just a model arrangement of two windings, starting winding and running winding. This one is a model. I want to just explain the basic principle, how this starting winding and running winding is going to produce a rotating magnetic field by using the phase difference I1 and I2. So I1 current is flowing through this winding, and I2 current is flowing through this winding. For a while, just ignore the direction of magnetic flux, magnetic poles produced. Just ignore all of them. Just take basic principle. Just try to understand the basic principle. Initially, I1 is building, but I2 has not started yet. So I1 is building. Consider it is building north pole here and south pole here. So here they has not been started yet, north pole and south pole. After 90 degrees rotation, here north pole and here south pole. But because of phase difference, they have not been produced yet. So north pole and south pole here. I1 current has reached up to its maximum position, maximum rate, and it's slowly decreasing. So while it is slowly decreasing, it is going to start to produce here north pole and south pole. After this current is reduced to 0, I2 current has maximum value. So here no poles, here no magnetic poles are produced, but here north south poles are produced. After this reaches to 0 position, it starts to produce magnetic poles in the opposite direction to the first one. That means here north pole and here south pole. And after this one reaches to minimum position, this one is producing in opposite direction That means now here south pole and now here. So if we observe north pole for one complete cycle, north pole is rotating. Firstly here, north pole, then after here, then after here, then after here, south pole, firstly here, then after here, then after here, then after here, and finally it came to here. So if we observe north pole is rotating, that means magnetic field is rotating. So phase difference between I1 and I2 is useful to produce a rotating magnetic field by arranging these windings in a proper way. In such a way, a rotating magnetic field produced around the rotor. This one, rotor. Rotating magnetic field is produced around the rotor, which is useful to make a ceiling fan self-starting. So friends, I hope you got a clear idea how a rotating magnetic field is produced in a ceiling fan using a single phase AC supply. We are dividing it into two phases which are 90 degrees out of phase to each of them. So that phase difference is used to produce a rotating magnetic field. Thus, a ceiling fan is made to be a self-starting.